Okay, this is an update on the DeLovely fusion reactor. Over here we've got the Divine reactor, the total fusion DeLovely. Okay, here's a little update. We're just doing a quick pressure test. So let me show you what's going on here before we get too far. I have a little leaking O-ring, but that's not going to stop this demonstration. So we have the dry gas coming through here, through this flow meter, and the wet gas coming from this flow meter. This is my gross valve. These are my adjustment valves for the dry and the wet gas. So let me just turn it on really quick so you can see. I'm just testing the gross valve, and now I can adjust the dry gas versus the wet gas. You see that? So I've got one quantity there. This one's the wet gas, so I can adjust the wet gas up or down, and the dry gas doesn't move. Then when I get it set, depending on the fusion reaction, then I can just open up the gross valve and get another quantitative. See that? So it's just a quick little pressure test, just to make sure everything is tight. And like I said, this gives us complete control over the gases. So we've got a little bit more to do on this, so it can be mounted to this apparatus so we can add pressure. But you saw this in the last video. This is where I decided that the vacuum pump is going to go, so we can pull some extremely high vacuum with this. If you don't pay attention to the videos, that's fine. But this goes on top. I've got quite a bit more machining to do on this, but this is relatively done. So we have taps on here, because in fusion, one of the issues is going directly from heat to electricity. So we've solved that problem as well. It's called Steamy energy. You can see that on my website under Steamy energy. And it's direct, 98% efficient, going from heat directly to electricity, with starting with only 4 to 6 degrees gradient of temperature. But we're going to have quite a bit more temperature in here. So the first update that you saw, I changed all the hoses to high temperature, a little bit more high flow hoses. It's Parker Hannafin. Right there. Parkflex PE. So it can definitely handle the vacuum or the pressure and the temperature, to make sure that we don't have any leaks, and it's relatively safe. Then I added the dryer over here, which will have a proprietary dryant in it. This will have our fusion. And so I'm not sure if I mentioned this before, but the fusion that we've accomplished is boron deuterium fusion, using hydrogen deuteride right out of seawater in situ, with a catalyst that gives us boron deuterium fusion. The most coveted fusion on the planet that has never been accomplished, with more than no joules out. We are at, you saw it, we're only at 100 to 500 watts in and 44,000 watts out. They say in fusion that it mathematically, chemically calculatable, that if you know how to control the magnetism, then you should be able to have a desktop fusion reactor. Well, here's your desktop fusion reactor. I'm going to explain this deeper. It's going to take me a day or so to finish this side of it. Then we're going to build on this side the Steamy cell that will recirculate the coolant. I mean the catalyst. The catalyst that I developed, my chemical chain, G, C, G for graphene, C for carbon, 36 slash HD, hydrogen deuteride, 54 slash O, 74. That's ozone over the black line. 7. On my avatar on YouTube, the green outline of the Cat's Eye Nebula, that is ozone 7 over the black line. And we achieve it with very high vacuum. Next, AU 197 M11 slash number 26. There's your update. Let's see if we can accomplish this again. We pulled 40.8 inches of mercury. Now, if I don't mess everything up and try to overthink this, and I just keep it simple stupid to what I know, we're going to see if we can go higher. Then, I guarantee you, this vacuum gauge and this vacuum gauge are going to peg. Once we get there, I'm going to pull out the mercury tube and we're going to go inches. And you're going to see something phenomenal. There's your update. Cheers.